Hirananda.
Good evening. 15 মিনিট শিক্ষাৰ আজিৰ অনুষ্ঠানলৈ তোমালোক আটাইকে আদৰণি জনাইছো। সকলোৱে জানে যে এইখন এখন অনলাইন শিক্ষা মঞ্চ। 2021 চনত কোভিডৰ বিভীষিকাময় পৰিৱেশত আমাৰ এই প্ৰয়াস আৰম্ভ হৈছিল আৰু আজি আমাৰ এই যাত্ৰাৰ 5 বছৰ সম্পূৰ্ণ হ'ল। এই অনলাইন শিক্ষা মঞ্চৰ জৰিয়তে আমি অসমৰ বিভিন্ন ঠাইত থকা কলেজীয়া পৰ্যায়ৰ বা হাইস্কুলীয়া পৰ্যায়ৰ শিক্ষাৰ্থীসকলৰ কাৰণে বিভিন্ন ধৰণৰ আলোচনা, তেওঁলোকৰ কামত আহিব পৰা বিভিন্ন ধৰণৰ বিষয় আমি আলোচনা কৰোঁ আৰু সেই বিষয়বোৰ যিকোনো এটা বিষয়ৰে হ'ব পাৰে। পদাৰ্থ বিজ্ঞানৰ হ'ব পাৰে, ৰসায়ন বিজ্ঞানৰ হ'ব পাৰে, অৰ্থনীতি বিজ্ঞানৰ হ'ব পাৰে, সাহিত্য, সাংবাদিকতা আদি বিভিন্ন ধৰণৰ আলোচনা আমি অনুষ্ঠিত কৰি আহিছোঁ। তাৰ মাজতে অসমৰ বিভিন্ন ঠাইৰ পৰা নিজৰ কষ্ট, নিজৰ প্ৰতিভাৰ জৰিয়তে পৃথিৱীৰ বিভিন্ন ঠাইত জিলিকি উঠা ব্যক্তিসকলৰ জীৱন পৰিক্ৰমাৰ আলোচনাও আমি এই মঞ্চৰ জৰিয়তে আগবঢ়াই আহিছোঁ। আজি আমাৰ এই যাত্ৰাৰ 5 বছৰ সম্পূৰ্ণ হ'ল। আজি 5 বছৰৰ যি পৰিক্ৰমা, সেই পৰিক্ৰমাক উদযাপন কৰাৰ উদ্দেশ্যে আমি এটা ফাউণ্ডেশ্যন ডে লেকচাৰ, প্ৰতিষ্ঠা দিৱস বক্তৃতাৰ আয়োজন কৰিছোঁ আৰু এই প্ৰতিষ্ঠা দিৱস বক্তৃতাৰ আমাৰ মাজত উপস্থিত আছে কম্পিউটাৰ ছায়েন্সৰ এগৰাকী বিজ্ঞানী ডক্টৰ অনুপম দত্ত। তেখেতৰ বিষয়ে আমাৰ গোটটোৰ সদস্যা ডক্টৰ সংঘমিত্ৰা গোস্বামীয়ে এটা পৰিচয় আগবঢ়াব। তাৰ আগতেই আমাৰ পৰিয়ালৰ তৰফৰ পৰা 15 মিনিট শিক্ষাৰ তৰফৰ পৰা আজি 5 বছৰে আমাক যিসকল শিক্ষাৰ্থী, যিসকল শিক্ষক আৰু যিসকল বক্তাই সহায় কৰি আহিছে আমাৰ এই প্ৰয়াসটোক, সেইসকলক আমি ধন্যবাদ জ্ঞাপন কৰিছোঁ আৰু আমাৰ আজিৰ যিটো অনুষ্ঠান, সেই অনুষ্ঠানটোলৈ আগবাঢ়িছোঁ। সংঘমিত্ৰা।
ধন্যবাদ হিৰণ্যদা. Thank you. Good evening and good morning to everyone. On the behalf of Team 15 Minute Xikhya, I would like to thank all our audience and speakers for their continuous support and encouragement. So today we are delighted to have Anupam Datta as our speaker for our 5th annual day lecture. So Anupam Datta is a very well-known and highly respected name in the AI community, particularly in the field of AI evaluation and trustworthiness. Hailing from Assam, he completed his schooling at Don Bosco School, Guwahati, and his higher secondary from Cotton College, Guwahati. He earned his BTech from IIT Kharagpur, followed by his master's and PhD from Stanford University. Professor Datta previously served as a faculty member in the Department of Computer Science at Carnegie Mellon University. He currently works as an AI research lead at Snowflake and is also an adjunct professor at Stanford University. The topic of today's talk is how can we evaluate the trustworthiness of AI. With that, I would like to hand over the platform to you, Anupam. Thank you so much.
Thank you very much, Sanghamitra and team, and thank you so much for the kind invitation. It's a pleasure to speak to this community. Moi actually Akomape Dangorhua, where Datta was a professor at Cotton College, and moi nije Don Bosco Guwahati aru Cotton College of Porhisilu. It is very nice to come back and speak to folks back in Assam. So let me start sharing. I want to talk today about trustworthy AI, meaning, as we have seen, artificial intelligence systems are now getting very broad adoption in many different fields in the world. And at the same time, it raises this question of how do we trust? How do we build trust in the outputs that are coming out of these systems? What kind of techniques can we use to enhance their reliability so that we can truly build reliable, trustworthy systems on top of core artificial intelligence components? So let me begin with a quick example. So back in 2023, almost say 2.5 years ago or so, I asked this question: who are the founders of Truera, of this system called Claude, which many of you may have played with. Claude, as well as ChatGPT, are very, very widely used now to support various functions, and in particular, question answering systems. So this is the result that it came back with. And what I'll highlight about this result is that it got many of the general trends correct. So there were 3 co-founders. This was also the area in which this company worked in, which is around evaluation and risk management for artificial intelligence systems. But a lot of the other specific details were incorrect. We were not founded in 2014. We were actually founded in 2019. Somesh Jha is a real person and is a good friend of mine, but he was not my co-founder, nor was Tomer Geva. And we were not acquired by SAS in 2019. So what you see here, the state of the world 2.5 years ago, there was just lots of hallucinations and mistakes that these systems were making. Fast forward to 2025. And now, when I asked the same question of Claude, it came back with the correct answer. So these folks are indeed my co-founders, and the accuracy or reliability of the results coming out of the system has gone up substantially. I'm curious, how many of you use ChatGPT or Claude for either for fun or for your work nowadays? Can I see a show of hands on Zoom? Okay, I'm seeing some hands up.
I think must be all.
Must be all would be my guess too. I just want to make sure that.
Yeah, almost every day, exactly as you say. Someone is texted in the box.
Good. Awesome, great. So these are very familiar technologies, right, at this point. And ChatGPT has what, like 800 million monthly active users. It's very, very widely used. But what I want to talk about today is a bit of this journey from back in 2023, when these ChatGPT-like systems were quite unreliable for lots of different kinds of questions and tasks, to where we are today, where things have gotten a lot better. Not all problems are solved. There's still room to improve, and I'll also highlight areas where there's active research. But at the same time, there has also been significant progress. And I want to start unpacking a little bit the building blocks that went into improving the trustworthiness and reliability of these systems. So before I go to agents, these kinds of systems like Claude or ChatGPT have evolved from just being large language models that are prompted to what are now called AI agents. I want to just quickly recap that under the hood, these AI agents are powered by foundation models or large language models that are being produced by companies like OpenAI, Anthropic. OpenAI has the GPT series. Anthropic has the Claude series of models. Google has the Gemini models. Meta was putting out open source models called the Llama family. There are the Mistral models, the DeepSeek models. This bottom row of models are open source, where the weights are available for inspection. And OpenAI, Anthropic, most of the Google models are closed source. You can access them by calling an inference API. And usually the way the agents are being built are by calling models over inference APIs. Good. So I'll just spend 2 minutes to give you a sense of conceptually how these foundation models are trained. And then for the rest of the session, I will focus primarily on agents, which are higher level systems, which can be used for question answering, for coding, and other kinds of tasks, which use these foundation models or large language models as building blocks. So foundation models are typically trained in 3 phases. And when I say foundation models, I mean models like the GPT models from OpenAI, the Gemini models from Google, the Claude models from Anthropic, and so on. So one analogy that I found very useful to understand the training process is this analogy is credited to Andrej Karpathy, who's a famous AI researcher, and he makes an analogy to how students learn mathematics, or some other subject. Like in this case, it's organic chemistry in the example in the book on the slide. So think about the 3 phases of training a large language model as analogous to the 3 steps in learning about a new concept. The first step is reading a textbook, where the purpose is to just read broadly and get a sense of, at a high level, what are the various concepts in that field. So pre-training a large language model like the GPT models is very analogous. In that phase, the way the model is trained is that it's given all of the text in the internet, and for multimodal models, it's not just text, it's also images and videos and so on. But it's fed that this entire body of, let's say, text for the purpose of the exposition, and it's trained to predict the next word or the next token given a sequence of tokens. And when you do that for a huge amount of data, like all the text on the internet, it's about, say, 15 terabytes or so of data, then the model starts to form a reasonable conceptual understanding of almost every topic that is represented in the internet. One second. Good. So that's pre-training. So pre-training is very useful to just start having that overall view of all the relevant concepts and topics that are represented in the internet. The next step is called supervised fine-tuning. In supervised fine-tuning, it's analogous to working through the solved problems in the textbook. So imagine that this is a a math textbook, then in addition to the description of the concepts, there will be a set of work problems, and that has a problem definition and a worked out solution which shows all the steps. Now, if you get tens of thousands of such worked examples, the model starts learning by imitation how to solve these kinds of problems. So this is a form of learning by imitation. So if you think of, and then finally, the third step is working through practice problems. And the analogous concept is called reinforcement learning. In practice problems, the difference between the practice problems and the solved problems is that in the practice problems, the problem definition is given and the final answer, the correct answer is given, but not how to solve it. So what the model does in this phase is it'll explore many different ways of solving the problem, and it has a way of verifying that it has figured out how to solve it by checking against the correct answer. The answer key is given, right? So reinforcement learning becomes a way to explore and learn new things. So much like students, the best way to learn a material is you first read the textbook, work through the work problems, that's like supervised fine-tuning, and then you work on the practice problems. And while you're working on the practice problems, you are now coming up with new strategies, potentially different from the ones that the work problems cover. And in that process, you're learning completely new strategies. But it's important for you to have a way to verify your answer, which could be either if you're working with a tutor, they will help you, or they can check your work, or you have that answer key, right? So the answer key is important here. But this combination of these three phases has given rise to really, really powerful models. So one thing I want you to remember is the imitation part of supervised learning versus reinforcement learning results in very different kinds of capabilities for the model, in the sense that here the model is only learning how to imitate previously solved problems, which is useful for it, but it's not coming up with completely new strategies. On the other hand, over here with reinforcement learning, it can come up with completely new strategies that no human has ever thought of before. And a good example of this was several years ago, Google had built a system called AlphaGo, which played this game called Go, and it was trained to play against itself through reinforcement learning over many, many epochs of training. And then it was put into these tournaments against the world champions in Go. And in one such tournament, it was playing the world champion in Go, the human world champion in Go. And in some point in the game, it came up with a very unusual move. All the experts, including the player that AlphaGo was playing against, at that time thought that this was an incredibly bad move and AlphaGo was going to lose. But a few moves down the line, it was very clear that it was such a brilliant, innovative move. No human had ever thought of it before, and AlphaGo went on to beat the world champion in that tournament. So this phase actually, if you think of these two phases, you of course need to build a foundation by reading the textbook, knowing about all the concepts that are out there as written by others. And then second phase is learning to solve previously solved problems. That's supervised fine-tuning, that's also very powerful. But finally, the reinforcement learning is what is pushing foundation models to go beyond what humans have even thought of. So some of you may have heard of the rise of reasoning models. So this started to gain momentum back in 2024 with OpenAI putting out O1 as the first reasoning model, then went on to also put out O3. DeepSeek had put out a DeepSeek R1 model. And since then, now if you look at the state of the art, a lot of reasoning models are used very extensively and have gotten to the point where they are solving international math level, Olympiad level problems. And the superpower here comes really from reinforcement learning. So in addition to these two steps, there's a huge amount of reinforcement learning that goes into training reasoning models. And they've gotten particularly very, very good at solving math problems as well as coding problems. So the rise of coding agents, the rise of general purpose reasoning models that do really well on math problems. There's the rise of AI co-scientists as well that are helping scientists not just solve very specific problems, but to even come up with new hypotheses for discovery of cancer drugs. These whole areas have opened up through a combination of these three techniques. So I'm going to pause here for a second and then start transitioning. This is kind of the end of my module on how foundation models, large language models are trained under the hood, and how that power has increased dramatically in the last few years as we have gone from initially just pre-training models to supervised fine-tuning to reinforcement learning. And that has provided the foundation for agentic technology to start being built with increasing reliability. We're not perfect. There's still a lot more work to do, but that's the next section of my talk. With that background on large language models and foundation models, how they're trained, I want to transition into how we have gone from this state of the world in 2023, where even simple questions like who are the founders of Truera ended up being dramatically incorrect in the final responses out of systems like ChatGPT and Claude, to where we are right now, where there's a fair bit of improvement in, quite a bit of improvement in the reliability of these systems. So before I go from 2023 to 2025, I'll take a short detour through 2023, 2024, which is also a useful intermediate step. So one observation I have to share, which is widely recognized now in the industry, is that AI research optimizes these large language models for generalization, and they actively penalize memorization, right? However, the intersection between these two areas is quite murky. So I gave you the example of who are the founders of Truera, that question. When that question was posed to a large language model a couple of years ago, it fell in this white region where, because not a lot of examples of this fact was in the training data, Truera was a reasonable sized company. We were about 50 to 60 people, Series B stage, but it was not like a world famous company. So there wasn't that much news articles about it that the model was trained on. So because there weren't that many instances of mention of the founders of Truera in the internet, it fell into this area, and this is not something the model reliably remembered. On the other hand, at the same time, even back then, if I asked the question, who are the founders of Google, ChatGPT and Claude both got it right every time. That's because there were lots and lots of references to the founders of Google in articles that were on the internet, the training data for the pre-training phase. And that fell in this intermediate region where that became more of a general fact that the model could remember. So with this kind of observation that some facts, like who are the founders of Truera, would fall in this category of specific facts, which the model may not do a good job of memorizing, whereas other facts, like who are the founders of Google, fall in this region. It becomes a general fact because there's so many instances of it in the training data. The tricky part is when a user is posing a question, you don't know, the model does not, or the user will not have a sense of how general or specific it is and where the line is when the model will start becoming reliable. And that's why we saw these instances where when we asked who are the founders of Truera, back in the day, the model was just completely wrong. So with this observation, the community started saying that we need to focus large language models on general tasks. Let's have them do summarization, embedding generation, logical inference, planning, these kinds of tasks, and leave memorization to something else. And so the question is, what is that something else? And back then, we saw the rise. Vector databases had been around for some time, but we saw the rise of vector databases where products from Pinecone and Chroma, Weaviate, Milvus started getting tremendous adoption as people realized that you can't simply question a large language model and get back a reliable answer. So in enterprise use cases or even consumer use cases, what you want to do instead is if you have a knowledge base over which you want to ask questions and get reliable answers, you don't simply call a large language model, you put that into a vector database in some form and then use retrieval over the database to get responses, and use large language models in the process, and I'll show that to you in a minute. But the source of truth is not simply questioning a large language model, it lives in a database. So that led to the rise of retrieval augmented generation, or RAGs, which continue to remain an important part of the overall architecture for question answering AI systems. And the idea there is, let's go back to my running example where we want to ask the system, who are the founders of Truera? So now what we are going to do is we take a knowledge base of information about Truera. That could be the website for Truera, other articles on the web that talk about Truera. We take that knowledge base, we break it down into smaller chunks of text, convert those into what are called embedding representations using an embedding model, and then put them into the vector database. And now when the user comes and asks a question like, who are the founders of Truera? The embedding model is used to translate that question into a query embedding. And then there's a retrieval step, which looks for information in the vector database that is most similar to the query. And then you get back a set of relevant chunks, and those chunks could, for example, have information about me and Xikhya and Will, and then those get these relevant chunks, the top pieces of text in the vector data retrieved from the vector database, along with the query, gets sent to a large language model to complete and produce the final summarized response. So if you look at this architecture, this is a sharp departure from the baseline architecture where you just go to a model and ask a question, which is what we were doing back in 2023. Instead, now the large language model is only being used for embedding generation and for completion or summarization, right? So if you think back to what I was saying with the general tasks for which we want to use foundation models, these two tasks are examples of general tasks, whereas the memorization is now put in the database. So the database remembers facts, large language models are used to generate embeddings and produce summarized responses. And so this architecture helped address the challenge with hallucinations or made-up facts that large language models historically have suffered from by putting the memorization burden on the database. It does not completely solve the problem because this summarization step can still introduce hallucinations, and the embedding generation is not perfect either, so there can be mistakes here. However, it's a big step forward. You also, the additional thing that you can do is called adding citations or groundedness, where you can cite results in the final response and say, for this fact, this is the source document. You can click on it and go check it out. So that was a big step forward. Because hallucinations don't go away completely, we still needed a way to evaluate these systems. And to do that, back in 2023, middle of 2023, 2.5 years ago now, at that time I was at Truera, we introduced this concept of a RAG triad. And the RAG triad captured 3 key properties that these kinds of retrieval augmented systems should satisfy. And it follows the structure of how the systems execute. So the first property was context relevance. With context relevance, we wanted to check, is the retrieved context relevant to the query that was asked? So if you think back to this architecture, when you do this retrieval, you get a set of relevant chunks or contexts. And for each such retrieved result, usually you will take some of the top results, maybe let's say the top 10 results, and ask the LLM to summarize them. For each of these 10 results, we are going to ask, is the retrieved context relevant to the query? And the implementation of this evaluation can actually be done with an LLM itself, an LLM, what's called a large language model-based judge that can evaluate how relevant each context is, each retrieved context is to the query that was asked. Next, we check for groundedness. In the final response, we are checking for every claim in that final response, is that supported by the retrieved context? And then finally, we check for answer relevance, meaning is the final answer relevant to the query that was asked? So now if we go back to our running example of who are the founders of Truera, if these answers came out through a RAG-like system where, say, that Truera website was the source of truth along with other articles about Truera on the web, then we can measure things like groundedness. So if you look at this more modern 2025 onwards system, then when it's saying that the founders of Truera are these 3 people and it's giving the summary, you also see over here a citation, which is a link to a web page. And this is an example of a groundedness evaluation, which is saying that for this fact, which is in the final response, this cited article on the web backs it up, has evidence in support of this claim. Similarly, the other articles also have support for this, right? So in the RAG world, you would have the retrieval augmented system would have retrieved these citations from the vector database and then cited them in the final response. But with the rise of agents, people had this additional insight that, well, not all of the information is static. And why should we limit our agents to just look in vector databases for facts? They can also look at other sources where truth resides. For example, let's just give them more general purpose tools that can search for information on the web. When the user asks a query, the agent, Claude, for example, Claude and ChatGPT are now agents that use tools to complete various tasks. So when I'm asking who are the founders of Truera, what the Claude agent did was it looked at its internal parametric memory, and it realized that it does not have high confidence information to answer this question. And the way it actually does that is by doing a consistency check, meaning that it runs that question through itself some number of times, let's say 20 times, and then checks in those 20 executions, did it always get the same answer or did it get different answers? For these kinds of specific facts, which aren't there in its pre-training data set in enough abundance, often the answers will be inconsistent. One time it might find these 3 people, another time it might find the results that I showed you earlier from 2023, where Somesh Jha and Tomar Geva were placed in here. So when it observes inconsistency in its results from just using its parametric memory, then it'll decide, okay, so I don't have high confidence information to answer this question. Let me use web tools and do a web search and see. So you see these 10 results here. These are the results that came from web search. And then what it did was, for each of those results, it assessed the relevance of that website for answering the question. And then, in fact, what ended up being the most useful set of chunks often came from this web article, which was about the Snowflake acquisition of Truera, right? So it assessed context relevance, then it produced this final response, and then for each claim in that final response, it added citations to ground them, and then finally the overall answer relevance for the full answer, right? So this, if you think back, is our RAG triad. So very similar technology, which worked for evaluation of retrieval augmented systems, starts also to work for agents. But we are not done, because for an agent, we don't want to just evaluate the final responses. It's also important to evaluate the process through which the agent arrived at this answer. Because among other reasons, the one reason to evaluate the process through which the agent arrived at the final answer is that agents can wander around. Many of these agents are like small children. They are exploring. If you give them a question, they might wander off and spend a lot of time exploring things that are irrelevant to the question that was asked. And then, although eventually they find the final answer, in the process, they incur a lot of cost, a lot of latency that ideally we want them to avoid. So that led us to do a deeper study to figure out how should we be assessing, evaluating the process of an agent? What are some of the kinds of metrics that we may want to do beyond these ones? And then finally, perhaps even leveraging that evaluation to optimize and improve the agent. So before I transition there, what I want to point out is that agents have these building blocks that they use. They plan, they use tools like web search, they reflect on the results of actions and adjust their plans based on that. They might have memory where they store some of the most important facts that they might need to refer back to as they continue executing. And for certain kinds of complex tasks, it's not a single agent that's working in isolation. You can have a swarm of agents or a multi-agent system where each sub-agent is focused on a narrower task and they work together to solve bigger tasks. So these are the building blocks for agents, and we saw them at work in this simple running example where, given a task, which was answer this question, the agent did some planning. It examined its internal memory, then it decided that there isn't enough confidence in the results, so then it made a plan to retrieve relevant information from the web. It got these 10 results, examined them, and then summarized them to produce the final answer, including adding citations. So in that process, it did planning, it used tools, the web search tool, it did reflection and assessed its results. For this simple example, there may not have been much need for memory, but it could have also kept track internally of the most important facts that are coming out through this process, which it'll then use to produce the final answer. So all of these building blocks can get used. Multi-agent collaboration tends to be used in more complex tasks, which I won't have time to get into today. So now what I want to do is get a little bit deeper into how we may want to evaluate agents beyond the kinds of metrics I covered here, which are primarily about the final outputs. So, and in doing so, let me just focus on data agents like deep research-like systems from ChatGPT. Snowflake also has a system called Snowflake Intelligence. And then before I get there, we were starting to already get into this, but let me just recap one of the key insights about how agents work. Agents will have goals. This goal could be, in our running example, often these goals are questions that they have to answer. But in a coding agent, the goal is, given a specification, a prompt of some coding task like building a website, that would be the goal, and then the task of the agent is to go build it. Once they have figured out what their goal is, then they will come up with a plan to achieve the goal. Then they act in accordance with that plan. And then there's kind of this loop. After performing some actions, they will evaluate how well, reflect on how well the execution is going. They can adjust the plan and then continue to act. And there's a loop till the goal is achieved or they have run out of resources like time or money. So goals, plans, actions. Now, if you look at the first letter of each of these boxes, that's GPA, right? So our main insight in coming up with a framework for evaluating agents that we call the Agent GPA framework for measuring the agent's goals, plans, and action alignment is that when agents fail, most of the failure modes arise because their goals, plans, and actions are not well aligned. Meaning that the plan may not be a good plan for achieving the goal, or the actions are not adhering to the plan, or the actions did not achieve the goal, and so forth. So a lot of these evaluation metrics fall into this framing of measuring an agent's GPA. I also like the word GPA here because of my academic and professorial connections, much like we measure the grade our students and they get a GPA. We are also grading our agents and they get a GPA too. And the GPA helps us understand where they're doing well, where they're not doing well, where there's room for improvement, and can inform optimization. So let's look at some of these classes of metrics. So the first set of metrics are what we call goal fulfillment metrics. They sit at this intersection between goals and actions, and they're measuring how well do these actions achieve the actions that the agent has executed, how well does that achieve the goal? So some of the examples are ones like we saw previously. Is the final answer correct? Is the final answer relevant? Is it grounded? So these are examples of goal fulfillment metrics. And we definitely want to measure whether the agent achieved its final end or final goal. But as I mentioned earlier, we also want to measure how well the agent is doing on its process for arriving at that goal. So the other metrics capture those. So if you look at now at this intersection between goals and plans, the plan quality metric is measuring how good of a plan did the agent come up with to achieve its goal. That's very important, right? Because if the initial plan was not very good, then the agent will go off on a tangent trying to solve a different task from the one that it was assigned to do. And then plan quality is not just about the initial plan. Based on how the execution results are going, it might need to adapt and come up with a new plan that will steer it towards solving the task better. Those are the kinds of things the plan quality metric measures. And tool selection is a special case of it, and it measures, did the agent pick the right tools in the right sequence to solve the task that it has been assigned. Plan adherence sits at this intersection. So plan adherence and tool calling sits at this intersection, and it's measuring, well, the agent came up with a plan, and it's maybe the plan said do A, then B, then C, but did it actually follow the plan and execute those actions, or did it deviate from the plan it came up with? So you'll find that while it might seem obvious that if the agent came up with a plan, it should follow through on it, it's not always the case that agents do that, because ultimately instruction following, models are not perfect at instruction following. Even if you tell them to do A, B, and C, it may not always do A, B, and C. It might do A and B and then forget about C and go off and do something else. So plan adherence helps us measure that. Execution efficiency, which sits over here, measures how did the agent actually take an efficient path to solve the task it was given. So this is where it might find that, well, the agent did some redundant actions. It went off on a tangent, it repeated certain things, and those were not very helpful. All of these metrics we have implemented using LLMs as judges. We're also doing work now on agentic judges, which we'll put out soon. These are available in open source in this TrueLens library that we have been maintaining. TrueLens has close to 150,000 monthly downloads. It's used quite a bit by developers. You can use it. It's a permissive license. I encourage you to play with it. Here's a running example, and then I'll wrap up. So if you look at this example, the agent receives the tasks. It's given this question: identify our largest client deal, then find important topics in meeting notes with that company, and find a news article related to the important topic. So in order to answer this question, the plan that the agent comes up with actually involves first using a text-to-SQL tool to find the largest client deal, then using a search tool over unstructured data to find important topics in meeting notes, which could be in Google Docs and such. And then finally, using a web search tool to find news articles related to the important topics. Now, when it came up with that final response, after doing all of this, the execution of the agent is logged, meaning all its steps it executed is, the execution trace is logged somewhere. And then the evaluations of the GPA shows that the agent came up with a good plan. It was logically consistent. Execution efficiency was good. Final responses were grounded, but answer relevance was actually quite low. And if you look at the answer relevance and then you see plan adherence is also low, what do you find? That it came up with a good plan, but it had to do step 1, 2, and 3. But while it completed step 1, 2, and 3, it did not complete. And because of that, it did not get the full answer. It only got one part of the 3 pieces of information, and that's why the answer relevance is a third. And this can also inform improvement to the agent. So you can fix plan adherence by adding more explicit sub-goals, and then from there, you can satisfy answer relevance with the missing context from the plan. So there's a body of work we are doing now where we are leveraging this evaluation to optimize agents in an automated way. That's a topic for a different conversation. We have done benchmarking. It shows about 95% recall. The blue lines are from our LLM judges. This is with respect to a data set called Trail Gaia, where the humans had annotated it, so we can compare how well our LLM judges are doing relative to human judges. And then the gray numbers are from prior work, so we're doing quite a bit better than that. You can get the full results here. We have a paper on this topic. And so you can follow. I'll keep this page up for a bit. You can read about the more details from this paper. There are sample notebooks. I also did a deeplearning.ai course with Andrew Ng. So this is a free course, about 2 hours long, which goes into a lot more details. But let me now wrap up. What I'll leave you with is foundation models are the core building block, and then agentic technology is built on top of them. And agents are, I would say, the most for me at least, the most exciting development right now in the world of AI is happening with agents. And one of the biggest challenges there is how do you ensure that you can make these agents reliable and trustworthy? And a lot of our work and a lot of other work in the community has also been focusing on that. Many sectors of the world are getting disrupted by agentic technology with humans in the loop. They are enhancers in many ways, and it's a very exciting area that I hope many of you will also get an opportunity to look at, and I hope this session was somewhat useful as an introduction. So let me stop here and open it up for questions.
Thank you so much, Anupam, for this wonderful talk on this very relevant topic that we all are going to deal, or we are always interested in, so that how to measure the effectiveness, or how to know that how true or the truthfulness of AI. And thanks a lot. And there are a lot of questions in the chat box, but before I go into the questions, I wanted to request Sanghamitra, so she has something to add. So Sanghamitra, please, can you please go for it?
Yeah, thank you, Anupam. Yeah, it's a very thought-provoking lecture, and I mean that's one of my interest area, evaluation of AI. So it's really nice to hear the talk, and yeah, as a part of the fifth annual day foundation lecture, like as an initiative, we would like to start an AI group, and we'll sponsor two students from 15-minute Xikhya platform to take classes on Udemy, and we can form a group, and we can discuss about the classes, because what happens, like online classes, if you take it your own pace, I mean mostly we like stop in between. So we thought, like, if we create a group and like have like regular discussions, we'll should be able to finish it and we'll get benefited by it. So some of us will be there too in that group, and then finally we can use, like, you know uh, learn those techniques and use those tools to create relevant AI related tool for students. So that's the initiative, and we'll announce more about it later. And yeah, we can.
Yeah, you guys can,
Like the-
anyone interested, maybe like we have students here, we have professors from different institutions, so it is definitely aimed at students. So any student can apply, whether they are undergraduate, postgraduate, or doing masters or PhD students, they can do it. And they can reach out to us. So they can email any one of us. We can give our email address here, and we will also give a Google form or Google Doc, so that you can fill out details later. Thank you. And before that, I also want to share the next lecture quickly. So we have a lecture series that is going on Nobel Prize. So for 2025, and our next speaker is talking on Nobel Prize in Chemistry for 2025, and he is Professor Debojit Sharma, who works as Associate Professor of Chemistry at IIT Patna. That's on March 8, 8:30 p.m. IST. So hopefully you will be able to join. Thank you. And now I think we can go to the Q&A session, please. So there are some questions in the chat box. কোনোবাই ইচ্ছা কৰিলে প্ৰশ্ন নিজেও সুধিব পাৰে, আমি আনমিউট কৰি দিব পাৰিম। চ' পাৰ্থ দাসৰ এটা প্ৰশ্ন আছে, আপুনি নিজে সুধিবলৈ মন কৰে যদি আপুনি নিজে সুধিব পাৰে। আপোনাক আনমিউট কৰি দিব পাৰোঁ, নহ'লে মানে মই ৰিড কৰি দিছোঁ। How true is that AI will take away a large chunk of conventional jobs and create equal numbers or even more jobs in other ways? how should we understand this paradox for our generation, which is still through building careers? And also, please comment specifically on AI impact on academic jobs.
Yeah, that's a very good question. I don't think that anyone exactly has the answer to this question. It's a hard question, but I can give you some thoughts. I think, for example, how software engineering is being done is changing dramatically, right? So, and we also need to change our education system to reflect that. So in the past, when programming courses were run in a very specific way, where a lot of the time was spent on connecting the concepts to syntactic constructs that reflect those concepts. And so learning syntax of a programming language was a big part of how programming courses were being taught. On the other hand, with coding agents, that's something that coding agents can do really well. Where coding agents have bigger challenges is assessing whether the generated code is reliable, is it correct, is it going to do what the specification was from the user was suggesting to do. So I think there will have to be a shift in how people are, computer scientists are trained to be more evaluation and testing and specification oriented. And then this, there has been, for example, some pullback in jobs in that area. But I think over time, it'll come back again with a different focus where the agents will be a big productivity multiplier, but the set of people who are specifying how tasks need to be done and then verifying that they were done in the right way, that skill, problem definition, focusing on the right problems. And that's the same thing for your question about academic jobs, that the job of even researchers, in addition to teachers, will have to evolve more towards not just on solving known problems, which the AI systems are getting much better at, but finding the right questions to focus on. And there'll be a churn. Certain kinds of jobs will get fully automated, but I would say that my advice is to stay on the edge of creative tasks and get much better at defining problems, because that quality, it's just going to be lots and lots of problems that one could put AI agents on, but being able to pick the right problems to focus on will be extremely important in creative areas like academia, but also in engineering.
Thank you, Anupam. There is another question from Nandini Rai. So Nandini, maybe I can unmute you. So can you please ask the question yourself if you're there? You can unmute yourself, please.
When we are using LLMs like ChatGPT, so how the responses are being validated internally, just little bit I want to understand on that, because when we are giving a prompt without saying with validate the response and a prompt saying validate the response, so there is a big difference in the output that we get. So like how internally it is getting validated.
Yeah, that's a very good question. I think it depends, like there's a set of possibilities here, and OpenAI and Anthropic don't tell us exactly what they're doing, but I can give you a bit of the sense of what is possible. So if, for example, you're asking it to validate, then it'll also do an addition. So some of these things are already happening. So if you look at, let me take a very concrete example. So if you look at ChatGPT, you will see that there you have a choice in the models that you use to power the responses to your questions. If you stick to a model that is from the more like standard track of pre-reasoning models, right? So like GPT-4o, for example, then as a natural course of things, it will not do certain things like consistency checking, meaning that if you ask it a question, it'll find one answer and then respond to you. But if you pick a reasoning model, which is, let's say, these later models like GPT 5.2, 5.1, and so on, and it describes to you which ones are the reasoning models, then the reasoning models will do additional validation. So they will take the same question, run it through themselves multiple times, and look for consistency before they respond. So like it depends a little bit on what your setup is, but I would say that for the first set, it will not do validation consistency checkings out of the box, but you can ask it to. Whereas if you're using a reasoning model or a deep research mode, for example, then the validation happens out of the box, but it's using more tokens. So if you have a token limit in your account, it'll cost you more money.
Thank you again. There is a question on Facebook from Ranjan Handik. So the question is, how does the interface arise between a super and hybrid computer and AI in finding out the results of relevant data, as for example, in population consensus adopting the PANS card like in India? I'm not sure if I could explain the question to you properly, but I just read it out.
Yeah, I'm not sure I understand that question fully. So maybe there can be a follow-up if there's a bit more detail on what the question is.
Right, I can ask that.
We are also over time. I want to be just mindful of people's time. Maybe
Right,
this
right. Right. No, it's okay. I mean, if you are free, we can extend it for a few more minutes, if you don't mind.
Sure, I can go for a few more minutes if there are more questions.
Right. Is there any question from inside? I have a question from myself. Like, so I am a physician by profession. So, like, there are some like LLMs which are dedicated to medicine. For example, one which is widely used is open evidence. So where we can ask questions, it comes up with answers with references. So is it so that with time we will actually need industry specific LLMs, or the LLMs like agents like ChatGPT and Claude, so their answers will be good enough? For example, I can see difference between when I use open evidence for a medical question as compared to ChatGPT or Claude, because open evidence will come up with all references and all. But ChatGPT can also come with references, but sometimes it hallucinates and sometimes the answers are not that relevant. So what's the future? Like, do we really have to use specific LLMs, and are we going in that direction for industry specific, or it can still be broad? Thank you.
Yeah, that's a very good question. I think if you remember I had this one slide where I was talking about the 3 phases of training. There's a pre-training phase, and then there is supervised fine-tuning and reinforcement learning. The second and third phases together are called post-training. So the common method to specialize a model to a specific domain is the pre-training phase is common, but then you post-train the models through supervised fine-tuning and reinforcement learning for a specialized domain like medicine. So what I expect is that for specialized domains, post-training for that domain is extremely important. So the models for to help physicians is going to be a post-trained version of a general purpose pre-trained foundation model. And then the question, like, so methodologically, I think that's the right way to do it. In terms of practice, there are people who are taking open source models and post-training them to specialized domains, and that's likely how open evidence was built. I don't know specifically about open evidence. We should look it up. What's the process through which it was trained? And then there is models like the ones from OpenAI and Anthropic, or a lot of Google models are not open source, right? So the post-training for specialization and customization can only be done by those companies. They have some basic open source models. So what I expect is part of their business model is going to be to post-train models, their models for specialized domains as well. Right. So the top level answer to your question is yes, we will see specialized models, and they'll come through post-training of general purpose models. And we will see that in open domain through post-training of open source models, but also through these large frontier labs are likely also post-training their models for custom use cases.
Any other question? Thank you so much, Anupam, for this answer. So thanks a lot. Because sometimes it is difficult as a user to get into specific models all the time, because I mean, if on my desktop ChatGPT is open, so maybe like I am a little lazy to open evidence again. So it's probably useful for from a user point of view that general models are able to answer those questions as well. But anyway, thank you so much for your answer. And another question I have from a user point of view is that now we have a lot of options, right? For example, there are already so many agents for daily use. You have Claude, you have Gemini, you have Grok, you have this, you have that. But as a user, how do we choose? Like which one to choose? Because if you ask the same question to the different models, it gives not exactly the same answer. Even though, like, I'm not talking about validity, maybe the answers are correct, but like it comes up with different ways. So as a user, you have a lot of options now. I mean, what do we do? Like, do we really need to know that what type of prompts or what type of questions are better answered by this model? Or we just rely on one particular model and go with it, because it's sometimes not possible to like put the same question on multiple models and then compare from a user point of view.
Yeah, there are no easy answers to this question, honestly. I mean, for most tasks between OpenAI, Anthropic, and Google, there isn't like huge differences, right? In the leaderboards, they're pretty close to each other. Google has pulled ahead a little bit in a few areas. And then other people are ahead in like coding. The Claude coding agents were doing quite a bit better than the others, but then the latest Codex one has also caught up. So those top three are pretty close to each other for most purposes. I think, I don't have like a definitive answer to give you. I think we are currently in that state where you experiment with all three and then you pick something that seems like you prefer for some reason, right? Like for coding agents, for example, there's more convergence around Claude Code right now. But who knows, like a month later, it might shift to another place. It's a tight race, and it's unlikely there's going to be one winner at this point.
Yeah, thank you so much again, Anupam. I think that I am finding it hard myself that which one to choose, but I thought that it would be not very smart to just rely on one, like agent, because otherwise probably I'm missing out on those who are probably having better answers to some things. I have a quick added question is that we are talking about democratization of uses and stuff like that across the world. So what is happening with languages? For example, say if we talk about a big country like India with so many different languages, and if we have all the chat like LLMs, which are of course mostly running in English, right? But what is the future? For example, someone who like to make it democratized, like to make it more user friendly to users of different stages of education. Somebody who is, it should not be only like reaching out to those people who are highly educated, right? It should also be reaching out. It should be just like a cell phone. I mean, cell phone in 2010 and smartphone in 2026 is a lot of difference. When you go to a small place in India, you see that everybody is using a smartphone. So what is the future? Like, how do we democratize it? Suppose somebody wants to use an LLM in their local language, say Assamese, say even another language, like I mean, any Malayalam or whatever. So where, which way is it going? Like how they can look at it? Maybe they are not that conversant in English. So what is the work going on in that direction?
Yeah, that's a very good question. Some of like Google Translate, if you look at something like Google Translate, it does cover a lot of languages, but not all. But some language, it has reached a broader set of languages than before. But I think the other part of the answer is initially the work on foundation models was led by the US and the Western world. And so there's a bias towards English in particular. But if you look at the models coming out of China, they're really good at now. A lot of open source models coming out of China, which are very good. And they are very good at Chinese languages. I think there are efforts in India to have support for Indian languages, foundation models that are trained on a lot of Indian language text. So taking open source models and then post-training them on, this will require some amount of pre-training as well, not just post-training. But I haven't closely followed this effort, but I think there are efforts in India that are, and other people here in the room might know about some of these projects which are looking to extend foundation models for Indian languages. That is definitely a very important step towards democratization. I mean, the other language is definitely native support for lots of languages. I think you're absolutely right. It's going to be very important for democratization. The interfaces are also likely to change, right? So right now we are doing a lot of typing, but audio and video interfaces are going to come in a big way in the next few years, right? There's some secret, like who was the guy who got hired by OpenAI? Who was the former Apple guy got hired into OpenAI. So there's going to be some kind of device coming out. And if OpenAI is doing it, so will be others. It's going to be some kind of device that people just, I don't know, wear around their neck and talk to. Or wear in their glasses. And you're absolutely right that the core foundation models have to become aware of many more languages, but also writing may not be needed. You can just speak to it or submit a video. Those multimodal interactions are going to become much more. Later on, we'll think of this typing stuff into ChatGPT, like that was ancient technology, and that might be just like a year or two away. It's not, things are moving so fast.
Yeah, I know. Just add to that, we already, in our company, we already developed voice-based AI. So it's already there in our organization. So if we can develop, I think it's not very far.
ChatGPT already allows voice-based prompts.
Yeah, it's voice-based prompts, but it's also going to be just the devices will be different. Like sitting in front of a computer and typing things will not stay the norm for too much longer. For some tasks, typing is needed, perhaps, like speaking about code. I mean, speaking about code is not perhaps too far away because you're just describing the problem and the agent is writing the code and you talk to it about. So, yeah, I mean, I think we're incredibly fortunate to see this huge shift in the technology landscape in our lifetime, and it's every 2 weeks there's a big shift in that. Something that seemed impossible not too long ago is becoming incredibly easy to do. So it's just so exciting that we are part of this revolution.
Thank you so much, Anupam. I think, Hiranyada, you have something to add?
I just listened, and you have already asked a lot of questions, which I thought I will ask, but thank you, Anupam. It was wonderful.
এটা মোর কোশ্চেন আসলে
to-
প্রসেনজিৎ
Please,
টাইম আছে নাকি এটা মোর কোশ্চেন আসলে
please go ahead.
ওকে অনুপম দা একচুয়ালি সাপোজ মই এটা বেলেগ কথা এটা সুধিব খুজিছো
Sure.
হেল্ল' sorry মোৰ মোৰ স্ক্ৰীনখন অফ হৈ গৈছে can you hear me now?
We can hear you, yes.
Okay, so suppose I have one son. He's like 5 years old, 5.5. Now if he asks any question to me and then sometimes I say that I don't know, then he asks that, okay, ask Google, something like that. Now what do you comment on this? Suppose those kids who are in school especially, or maybe what about like how these AI will like maybe I mean affect their cognitive abilities, because from a very young age they are using this, probably in schools they are using any answers to the questions, right? So now AI models are even solving international mathematical Olympiad questions as well, right? But then some kids will use it, I mean, for every questions, right? Any questions, whatever it is. So now how they impair, I mean, the cognitive abilities of the young kids?
Yeah, that's a very good question. I have a 11-year-old daughter as well, and when she asks questions and I don't know the answers, I do the same thing, that we check with Google, and we've been doing it for many years. I mean, I think it's a very good question. Again, like many questions that were asked today, I don't know the answer, and I'm comfortable saying that I don't know. But among the things that I think will, like the education system for children will have to dramatically change. What is foundational that kids will have to learn to do themselves is preserving critical thinking skills, right? That is something the education system will need to support. So if you think about how we grew up, there was a lot of rote learning and memorization. And in those days, actually, it was okay because the ability to retain facts was very important to do critical thinking when you face a new topic, right? We were doing debates on various topics, and if you have to debate in real time, not just in school, I mean, but also like think about public debates and so on, being able to produce those facts from memory was important to make the right kind of argument. And then when Google emerged and search engines emerged, the retention of facts in human memory was not that important anymore. And so education system has, I mean, I'm not so much on top of the education system in India, but when I look at my children and my child and how she learns, there is not a lot of emphasis on memorization in most of our education system, right? Because facts can be looked up, but that doesn't mean that there is no emphasis on, but the emphasis on critical thinking still remains, where they're doing more problem solving and reasoning. They're critiquing literature and things like that, which remains a very valuable source. And now I think the question is, because our AI models can solve these really hard math problems, they can come up with scientific hypotheses. It's one step beyond the looking up facts, right? It's able to do reasoning. Does that mean that what does critical thinking mean now for our children, right? Can they just use them as tools to do reasoning on their behalf? I think there will be a shift where the kinds of reasoning that was considered essential for critical thinking before will get outsourced to these tools. Much like computation has got outsourced to calculators. Like, we were not allowed to use calculators till we went to college. But from college, we didn't have to do the large math, right? Like large math computations. We could use calculators. I think some reasoning tasks will get outsourced, but that's not necessarily a problem. I don't know exactly what kind of the entire space of critical thinking skills that still need to be retained. But one thing that absolutely will need to be retained is taste for problems. Like, what are the most important? Being able to critically figure out that these are the most important problems for us to work on, and being able to communicate that and specify the problem statement itself. Like, most of the leading researchers in the world always had that. That's what distinguished, say, Jan LeCun or Jeff Hinton from many other people who worked in AI, that they had that taste in problems, the foresight that this type of technology will stand the test of time, that it's important to figure out how to train certain kinds of models. So I think like that skill, that's one skill that I think is extremely important. Even if the models can do reasoning well, figuring out which problems to focus on, what the problem statements are, how to evolve those statements in response to almost like an interactive dialogue with a agentic tool. And then being able to verify, I mean, the problem that you were also saying earlier, which is I can use 3 different tools and I get 3 different answers. Like, which one should I pick? That, I think, will stay in the human domain for some more time. The focus on problem selection, specification of problem, verification, refinement, that's that space. And that'll have to start in early education as well.
Thank you. Thank you so much.
Thank you. Thank you, Anupam.
Sorry, Prakhanjit, you were saying something?
No, just thank you. That's a very elaborate answer. Yeah, thank you.
Thank you. So actually, the question that was there on Facebook from Ranjan Handik, so there is a follow-up and explanation of it. So what Ranjan is saying that, yes, specifically the difference between a supercomputer and AI in perspective of population data in our demographic profiles. Am I?
Right. And the supercomputer versus AI is a difference, I think, between hardware and software, right? So when I was in grad school, the folks who claimed that they were working on supercomputers, those are the same folks who are now running things at the hardware teams at NVIDIA and the data center teams at Google, right? What used to be called supercomputers are now called data centers. And this is GPU hardware, highly parallelized to support lots of kinds of operations that the AI models running on top of those hardware have to do, like training makes use of the hardware platform from these data centers / supercomputers, inference, which is when you are typing into ChatGPT some question, it's triggering all these inference calls in the back end on these platforms. So, and then I don't know a whole lot about population studies, so that sounds like a specific kind of application, which also feels like a highly parallelizable kind of task, which these hardware systems are well suited for.
Thank you so much. Quickly, another question is that in the current education system in the context of India, so which chatbot you think is more convenient for users?
I don't know. I will let you answer that question, or someone who's because I haven't kind of looked at it with that India lens. But as I said earlier, the frontier ones from OpenAI, Anthropic, and Google are all pretty close. So for most tasks, they'll be equally good. But if there's something very specialized,
I think Rifat, we are
Yeah.
over time,
Yes.
and Anupam may have some work.
Yeah, we can conclude. And one last question, I guess, that how close are we to artificial general intelligence? There was another question. Last question.
Yeah, that is also a very good question. I think some people claim we have already gotten there, and some people claim that we are 10 years away. So I think it depends a bit on the definition of what that means, but if you look at the foundation models, they're generally very, very good at lots of things now. Where there is still gaps is understanding the physical world. And there's a good amount of work right now on world models, which are trying to address that gap and have more deeper representations in the models for understanding of the physical world. So that's an area where people like Yann LeCun, Fei-Fei Li, lots of leading AI folks are. Google put out a world model recently, using it for simulation for automated self-driving cars. So part of the answer to these questions depend a little bit on who you ask. But if I look at some of the folks that I respect, like Yann LeCun or Andrej Karpathy, their sense is we need another shift in technology, not with large language models themselves, but getting into world models which understand the physical world better before we will get to AGI. And that's probably, in their estimate, somewhere between 5 and 10 years away. And then there are folks like Dario Amodei from Anthropic and Sam Altman. These guys are more gung-ho about LLMs getting us there, and then the timeline is 1 to 2 years. So I am a bit more in the former camp, so I think we are still 5 to 10 years away. But you can pick your poison.
Thank you, Eric. Thank you so much again. I think we can conclude now. Hirendra, please go ahead. Thank you so much, Anupam. Sorry, we have exceeded the time. We apologize.
Oh, thank you so much. This was fun.
Hirendra, please.
Thank you very much. Thank you, Anupam, for such a wonderful lecture. And more than lecture, I enjoyed your answers to the questions. It's an evolving technology. We don't know a lot. Of course, you are in the forefront of this area of research. So you know a lot more than we do. Thank you for giving us time. We went a little bit over time. We are sorry for that. And also we would like to thank all others who attended this lecture, and in future, hopefully they will also, because we will have this recording archived in our YouTube channel, so they will get to see it. Hopefully it will be very useful for all of us, irrespective of what they do. Again, thank you, Anupam, Datta, for your time and for giving us this wonderful lecture. And thank you, everyone, for attending. And on behalf of 15 Minute Xikhya, we would expect, or we would hope, that you will keep supporting our effort. Our next lecture is on 8th of March. It is on the Nobel Prize, 2025 Nobel Prize in Chemistry. Thank you and good night.
Thank you all. Thank you. Oh, we are not live anymore.